Hi, today's session is going to be looking at algebraic fractions and simplifying bits like that. The reason we're going for this before the solving equations is because actually these skills are very important if you want to be able to solve those higher level equations. So I thought it's best if we cover those first. So if I let me share my screen, we're aiming, like algebraic fractions is generally sort of a hitting grade 7, 8 into grade 9 for some really difficult ones. What our aim of today's session is to be able to be confident in adding, subtracting, multiplying, dividing algebraic fractions and look at simplifying them into their simplest form. So I say it's all algebra based. If you're thinking about A-level maths, this is a really key kind of area to get your head around. So algebraic fractions. So let's start with what is an algebraic fraction. So an algebraic fraction is exactly the same as a numerical fraction. We need to be able to simplify algebraic fractions to their simplest term. Now, by that, it's exactly the same as a numerical fraction. So if you just think back to a numerical fraction, if we had like 12 over 30 and I wanted to simplify this to its simplest form, I look for a common factor. I'm looking for a number that goes into both 12 and into 30. So, and then I divide both the top and the bottom by that same number. So 6 goes into both. That would be 2/5. So numerical fraction, it's looking for that common factor. With an algebraic fraction, it's exactly the same process. You are looking to find a number or a letter that goes into both the top and the bottom line, and you can only simplify it. To simplify it, you must only do it if you can take out a factor. So 5xy and 15x, if we look at this first one. But you know what? I can see straight away 5 goes into both. So if I was to do it in steps, I'd divide it by 5, which would leave me with xy over 3x. So I've divided both the top and the bottom by 5. Now, if I look at that again, there's actually a higher common factor. So we're always going for the highest common factor we can get, like we do in numerical fractions. There is also an x in both, so I can simplify. We say we cancel out the x, but what we're actually doing is we're dividing both the top and the bottom by x, which would leave us with y over 3. So we can do that in one step, multiple steps, it does not matter, but you're looking for that common factor. So that first one, look, 5 divided by 5 divided by x. Now the second one here, first thing we want to be able to do before we try and simplify, we need to factorize, because we can only simplify if we have a common factor. So when you're thinking algebraic fractions and there's more than one term, you want to factorize first in order to simplify. So look at 12x minus 4 and 24x. What number go? So we'll simplify the top one. I can pull out a factor of 4 out of that top line. So I get 4 bracket 3x minus 1. Can't really factorize the bottom because it's only one term. Now, when I'm looking to simplify, I'm looking for a common factor. So 4 is a common factor. 4 goes into both. If I divide the top by 4, I'm left with 3x minus 1. If I divide the bottom by 4, I'm left with 6x. That is the simplest term. I cannot cross out the x like some people like to, because it is not in every term in the equation or in the fraction. So it has to be a common factor in order for me to be able to simplify it. So factorize first. Okay, then for the next one, let's look at factorizing that top line again. So remember, when you're factorizing, you're bringing out the biggest factor you can. So 3 goes into both 15 and 21. There's also an x in both. So I get 3x, 7y plus 5. So this will also be a really good practice for your factorizing skills. If you know you're weak at factorising, I would suggest you probably do a little bit of factorising practice first. One term on the bottom, so we don't factorise that. Now we look and see, do we have anything in common? Well, actually, we've got an x that's a common factor on both, and we've got a 3. So I can divide by 3x, which means I'm left on the top with 7y plus 5. On the bottom, if I divide by 3x, I'm left just with 4, because what will happen is that the x's cancel out. 3's into divide by 3 just leaves us with 4. And that is a simplified fraction. So let's just recap there. To simplify, first you must factorise. So always factorise first. And as I say, great practice for your factorising. That'll help you with solving quadratics. That will help you with the solving some harder equations. That'll help you find out where quadratic graphs are crossing the x-axis. So it's all practice, all linked in together. So factorise first. So then we get a question that looks like this, and we've got to simplify this. So let's remember our rule. Our rule is before we do anything, we need to factorise. Now, we've got to factorise both the top and the bottom line, so both the numerator and the denominator. Now, hopefully you've spotted these are quadratics because they're x squareds. They've got a number on their own, which means there's no common factor in each term, so it's going to be a double bracket. And then on the bottom, it's also going to be a double bracket. So to get the x squared, we're going to have x and x. I need two numbers that times together to make -5. So they've got a times, remember, to make that one on the end. I've got two numbers that add to make -4. So they've got a times to make -5 and an add to make -4. So it's going to be 5 and 1. That makes 5. So one of them's going to be negative, one's going to be positive. So I've got -5 plus 1. Bottom line, x and x. I want two numbers that times together to make 6. They've got to add to make 7. Now I've got a little bit of a helping hand here. I know, because it's asking me to simplify, I know that one of them is going to be the same as one of the fractions on one of the brackets on top, because that's how I simplify. So to multiply to make 6 would be 6 and 1. Add to make 7, so +6 plus 1. If it asks you to simplify an algebraic fraction, you will have a common bracket on both the top and the bottom. So we can cancel out that bracket with that bracket because they're both the same factor. And that leaves us with x -5 over x plus 6. You can either include the brackets at that point or not. It does not matter. Now, the trick is, when there are slightly harder ones, always factorise the easier one first. Factorise the one you are more competent with, because that kind of gives you a hint on the second one, because you know one of the factors must be the same. So it's always worth factorising the one that is easiest first. And we can't do anything else with that because we don't have a common factor. Remember, always common factor. So this one's a little bit tougher. So this is kind of like your harder factorising quadratics. So in order to simplify, remember, we must factorise. That's why they can see me now. We must factorise. So again, we've got quadratics. We've got no common factor in the top row. So that means it's going to be 2 brackets. we have no common factor in the bottom, so that's going to be 2 brackets. Now for the top row, what you may have noticed is this is what we call a difference of 2 squares. Now, that is a certain type of factorization. What that means, 4x squared is a square number. 4 is squared, x squared is squared. 25 is a square number. We're finding the difference between them, we're taking them away. That's why it's called the difference of 2 squares. Now, in order to factorize that, all you need to do is square root both. So the square root of 4x squared is going to be 2x. So each bracket is going to have a 2x in it. Square root of 25 is 5. So each bracket is going to have a 5. And then one will be positive, one will be negative. So if it's 2 square numbers and they're being taken away, it's what we call the difference of 2 squares. Now, the reason we did that one first is because that's the easier of the two. The second one, we have to be able to multiply to make 6x squared. Now, if we just started with that, we could have had x and 6x, we could have 2x and 3x. A couple of different options there, and then we'd have had to think about the other numbers. Now, because we've done the top first, we know that one of the factors has to match. So one of them is going to be a 2x, and one of them is going to be a 3x, because that will make my 6x squared. Now, I know that with the 2x, there's got to be a 5, because it has to match one of the ones up the top. Don't know if it's positive or negative yet, but I know it's a 5. So that means to multiply to make minus 10, that's going to have to be a 2, because 5 times 2 is 10. Then I just need to work out my symbols. So here I know one is negative, one is positive. So I'm either going to have 5 and minus 2, or I'm going to have minus 5 and 2. Now they have to add to make minus 11. But remember, when you're expanding out, you've got to take into account the 2x. So here we're going to have 2 times 2 and 5 times 3. We've got to decide where the negative is. So if I had 5 times 3 is 15, I want that to be a minus 15. So it'll be minus 15 plus 4x. So yeah, just think if you're expanding out, I'll just do it over here so you can see. Two x times 3x gives us 6x squared. 2x times 2x is 4x. Minus 5 times 3x is minus 15x. Minus 5 times 2 is minus 10. Combine the minus 15 and the 4. That makes you minus 11. Good. And then if we look at our thing, we have got 2 factors the same. So that one is going to cancel with that one, which means our simplified fraction is 2x plus 5 over 3x plus 2. And that's it, magic. Good. Hope that's making sense. It's always factorize the easiest one of the 2 first, and then use what you know from that top line or the easier one to help you factorize the harder one. So that is how you simplify. You factorize first. Next thing we're going to look at is we're going to look at adding and subtracting. So to add and subtract fractions, just the same as numerically. If I said to you, what's 3/4 add a 5th? You can't do that unless you have a common denominator. So to make your common denominator, you're looking for the highest common factor. So in this case, it'll be 20. Remember, whatever you times the bottom by, you times the top by. So that will give you 19 out of 20. So you're looking, again, that highest common factor. Or lowest common multiple to make, lowest common multiple to make the denominator the same. You do not want to be multiplying, especially with when you get x's and things involved, you don't want to be multiplying and making big powers of x if you can help it. You want to go for the lowest common multiple that you can, because it's not very easy to multiply, to simplify down when you end up with lots of different powers. So if we were going to look at this first one, we've got to make a common denominator. Now, 4 and 5, completely different numbers. One of them's got an x on it. So what we're going to do is we're going to multiply them together in this case, because there is no simpler way of getting a common denominator. So I've times the 4 by 5x, which means I've got to times the 7x by 5x. So 7x times 5x is 35, 7 5 is 35. X times x is x squared. I've times the 5x by 4 to get 20x, so I must times the 3 by 4, which gives me 12. I then can add my fractions because my denominator is the same. Remember, the denominator stays as it is. So 35x squared plus 12. I look and see, can I simplify that? So can I pull out a factor out of that top row? Is there a number that goes into 35 and 12? There is not in this case, so that is the simplest form. So you make that and then try and simplify at the end. Yep, so you're finding, step one is you're finding your lowest common multiple for the denominator. Okay, then we've got x plus 1 over 3 plus x over 4. So we want the lowest common denominator. Doesn't matter what's on the top, we're just looking at the bottom line. I've only got a 3 and a 4, that's quite a straightforward one. I can make that 12. So I've times this one by 4, which means I've got to times the top line by 4. Remember, when you're timesing it by 4, you could put 4 bracket x plus 1 close bracket, or you could do 4x plus 4. I times the 4 by 3, so I've got to times this one by 3, and I get 3x. Now I have my common denominator, so I can combine 4x plus 3x is 7x plus 4 over 12. Can I factorize that top line? No, I can't. That's in the simplest form. So you're finding your lowest common multiple for the denominator. Then you do your addition. Then you look and see, is it possible to simplify? Sometimes it will be, sometimes it won't be. Let's have a look at these ones. So for these ones, remember, you want to aim for your lowest possible denominator. So I could times them both together and have 6x squared. But actually, that's not my lowest possible. That's an extra power I have to deal with. I could just multiply the first one by 3 and the second one by 2, and that way they'll both become 6x. 6x is simpler than 6x squared. So we want to go with the simplest. I'll show you what you get otherwise, just to show you that it would work, but why it could be harder. So I'm timesing this by 3, I times this by 3. So I've got 3 over 6x plus 2 over 6x, because I times those by 2, which gives me 5 over 6x. Can't simplify that, both common. Now, if I'd have done it with 6x squared, so if I'd have times the two together, I'd be timesing that by 3x and that by 2x. I would have ended up with 3x over 6x squared plus 2x over 6x squared, which is 5x over 6x squared. I could have then simplified it down to get that. Now, the problem with doing that, this was not too bad, this one, to simplify down. The problem with doing that is when you have like brackets to different powers, you suddenly end up with all kinds of like x cubed expressions and things like that, which are a lot harder to factorize and simplify down. So you always want to try and keep it in the simplest possible to start with. Okay, a half minus 1 over 2x squared. So I'm going to make my lowest common multiple for this one 2x squared. So I'm going to multiply this by x squared, which means I've got to multiply this by x squared. If it helps you to put your little notes on what you're timesing, to remind you to times it, do that. So I get 2x squared. On the top, I've got 1x squared. Second fraction, I don't need to change because the denominator is already 2x squared. So you see it saves me expanding up. I can now combine them. I end up with x squared minus 1 over 2x squared. Now, can I simplify that? The only way I could possibly simplify is by factorizing the top line. Now, I can actually factorize the top line. This one is what difference of two squares. However, by simplifying or by factorizing it, it doesn't have anything in common with the bottom line still, so I can't simplify it. But that is what you need to double check for and keep your eyes open for. Sometimes there are the x squareds where you can. There are difference of two squares where you can. Excellent, okay. Doing well. Hopefully it was making sense. Subtracting, exactly the same as adding, except you subtract. So you look for a lowest common multiple. Now, when you've got two like this, what I'd do is put them in brackets. So you remember they go together. If you've got two brackets like that, and only numbers on the top, double check that you can't like factorize and simplify. You can't on this one. So we'll make our common denominator simply x plus 5, x minus 1. Notice that I am not expanding out. There is no point in expanding out the bottom line, because in order to be able to simplify, you have to have it in factorized form. It's already factorized. So we're timesing this first one by x minus 1. So you've got to times the top by x minus 1. So we get 7 bracket x minus 1. We times this one by x plus 5. So we've got to times that one by x plus 5. So we get 2 bracket x plus 5. You can expand your bracket straight away on the top because you will need to be able to in order to compare them. So I'm doing steps so you can see 7x minus 7 minus 2x. Now be careful because it would be minus 2 times 5, so it'd be minus 10. And the bottom line, oh no, that's a minus. There's x plus 5, x minus 1. Let's simplify, so we've got 7x minus 2x is 5x minus 7 minus 10 minus 17. And again, keep that bottom line factorized all the time, because if you're going to be able to simplify, it has to be factorized. Yeah, so just to double check you've got that. When I expanded this one out, I had minus 2 times x and I had minus 2 times 5. That's why it became minus 10. I can't factorize the top, so that is it in the simplest form. So then we move on to multiplying, dividing, and then we'll start looking at some of the exam questions. So multiplying and dividing, again, same as numerically. When you multiply algebraic fractions, or when you multiply fractions, so think 3/4 times 1/5, you multiply the top line, multiply the bottom line. So yeah, 4 times 5 is not 15. So that'll be 3/20. Now, sometimes, if you remember, you can simplify. So if you've got like 9/10 times 2/3, remember you can simplify before you do the timesing. Now, it's up to you whether you do this. You might find it easier to do this with algebra. So here, because I've got a 3 on the top and the bottom, a factor of 3 on the top and the bottom, I could divide by 3. I've got a factor of 2 on the top and the bottom, so I could divide by 2, and I end up with 3 times 1, 5 times 1. So this one I have, remember, you might want to put them all into brackets to remind they're grouped. I have an x plus 1 on the top and the bottom, so I can actually just simplify that and that, which means I'd be left with x minus 5 over x minus 7, because that would be a 1, that will become a 1, because you've divided them both by x plus 1, and that's it simplified. You could have times them first. Remember, don't times out the brackets because you want them in factorized form. Okay, on to number 10, no, page 10. So we've got this time 4 over 2x minus 1 times 6x minus 3, x plus 7. So first step, always look and see, can you factorize any parts before you multiply? So 4 can't be factorized, 2x minus 1 can't be factorized. However, 6x minus 3, I can pull out a factor of 3. So I've got 2x minus 1 over x plus 7. Remember, if we put it in brackets, we don't forget they're together. 2x minus 1 on the top and the bottom, so they cancel. This only works if it's a times in between them, by the way. Don't do it if it's a plus. 4 times 3 is 12 over x plus 7. If you prefer to write it out, do the multiplying first and then cancel it out, that's absolutely fine. So you'd get this, and then you can see the 2x minus 1s cancel. So if you prefer to write it like that, then cancel it. That is absolutely perfectly fine. And you see you're left with 12 over x plus 7. So it's all about thinking about, can you simplify as you go? Dividing, remember, to divide a fraction, I always teach it as KFC, keep, flip, change. So keep the first fraction the same. So I'm going to have 4 over x minus 2 stays the same. Flip the second one upside down. So I've got x squared minus 2x over 3. Change the sign to a times. So just by writing that step, you're scoring yourself 1 mark. Now look and see, can you factorize anything? So the first fraction, I cannot factorize. the second fraction, I can pull out a factor of x. And all of a sudden, look, I've got an x minus 2 on the top and the bottom, so I can get rid of that. And that become a 1 if it's left by itself. So that would be 4 times x, it's 4x. 1 times 3, it's 3. So it'd just be 4x over 3. And that is it simplified. So you've always got to look and see if you can factorize as you go and simplify as you go. So let's look at some exam questions. Because what exam questions tend to do is they tend to incorporate all the skills into like different bits. So 3 marks. And they word them a bit differently. So you've actually got to do a bit of just thinking about it. So A and B are positive values. Show that 7a plus 2b minus 3a over 8a plus 6b plus 2a minus b always simplifies to the same value. So even if you're not entirely sure, it says, first of all, it always simplifies. So think about what can you do, can you simplify? So let's simplify the top first of all by collecting our like terms. So we have 7a and 3a. 7a minus 3a is 4a. We've still got plus 2b. So on the top, we've got 4a plus 2b. On the bottom, we've got 8a plus 2a. So that is 10a. I've got 6b minus b, so that's plus 5b. So then remember, when we're simplifying, we want to say, can we factorize? Can we find a common factor? Well, I can bring out on the top line a factor of 2. So that will leave me 2 bracket 2a plus b. On the bottom line, I can bring out a factor of 5. Oh, and look what's happening. We've got the same common factor now. We've got the same common factor. So I can divide by 2a plus b. That leaves me with 2/5. So when it says it simplifies to the same value, whatever a and b are, it doesn't actually really matter, because when I put it in and simplify it, it just comes out as 2/5. So on that question, that's what you're trying to do. You're looking for those keywords, simplifying it. If it says it always comes out to the same value, you'll end up with a constant number. 3 marks. Good work. Then we've got a multiplying fraction to simplify. So simplify. Now, remember, you can simplify as you go, you can multiply, then simplify. It's up to you. So I'm going to say, look, I've got a 5 on the bottom. This is a factor of 5, so I can divide by 5. I've got an 8 on the bottom, a 2 on the top, and I've got an 8 on the bottom. So if I divide those by 2, I get this. I've got, oops, don't want 2 more equal signs. So I've got 5a times a, which is 5a squared. I've got 4 times 1, which is 4. Alternatively, you could have done 25a times 2a, which is 50a squared. 8 times 5 is 40. And then you go, oh, look, 10 goes into 50 and 40. Gives you the same answer. So you can see why simplifying early sometimes makes it easier, sometimes it doesn't matter. Okay, express as a single fraction. Simplify your answer. So a single fraction means I want just one fraction. Simplify my answer obviously means I want to take out any common factors. So first thing I need to do is I need to decide what is going to be my denominator. Now, I can only make a common denominator by timesing or dividing, so I can't just add 1. So I'm going to, in this case, because they're just two completely different things, I'm going to multiply them. I'm going to put some brackets to make sure I don't get muddled up. So I'm going to multiply that by n and that by n plus 1. So remember, whatever I do to the bottom, I do to the top. So I end up with n plus 1 over n plus 1 minus we're doing plus, isn't it? So minus n plus 1 over n plus 1 . So let's expand out. So we've got nm plus n minus mn. Be careful, it's minus m plus 1, so minus m. Excuse me. All over n plus 1. It's not looking very simple at the moment, but remember, mn is the same as nm because you're just multiplying. So that one and that one will cancel because one is positive, one is negative. So we'd be left with n, take away m, over n plus 1. Remember, no point expanding out the bottom line because if you want to ever simplify, you need it in factorized form. So that is the simplest form for that one. Excellent. Hopefully we're getting our heads around these. You may be going ahead from me, trying it with the video paused. Great, double check your answer, confirm you've got it right. So write as a single fraction in the simplest form. So again, look, we've got plus, so we need a common denominator. We don't have anything in common already. Treat them as a fraction, you can't just add and subtract. So I'm going to make my common denominator x minus 1, x plus 2. I do apologise for my handwriting on here. For some reason, my board's not working very well. So I've times this first fraction by x plus 2. So I've got to times the top by x plus 2. So I can put it in brackets or I can just expand it straight away. So I get 3x plus 6. I've multiplied the second fraction all by x minus 1. So again, I can put it in brackets or I can expand. So 4x minus 4. I can combine it to make a single fraction. So single fraction, remember, one fraction. So 3x plus 4x is 7x. 6, take away 4, plus 2. No point expanding out the bottom unless it asks you to, because then you can simplify if need be. So hopefully you will manage to get that answer. Good work. See, these aren't so bad after all. Nice little 3-4 markers. And all you've got to kind of do is think about all your skills, factorizing, simplifying. So simplify x squared minus 16 over x squared minus 3x minus 4. So Think back, simplify. You must factorize first. So x squared minus 16 is actually a difference of 2 squares, remember? Because x squared is a square one, 16 is a square number, and you're taking them away. So that means we've got a positive and a negative. Square root of 16 is 4, so you've got x plus 4, x minus 4. Bottom line, well, we've got an x and x. We know we're going to have a 4 and a 1 because we need one of our fractions to match the top one to simplify. 4 times 1 is 4. So I need 1 to be a negative 1. I want it to add to make minus 3. So if I do minus 4 plus 1, that makes minus 3. I have a common factor in x minus 4, so I simplify. And my answer is simply x plus 4 over x plus 1. Again, leaving the brackets in at this point does not matter. Either way. That's a nice 4 marker, isn't it? Let's hope that comes up in your exams. So it's factorising. So for 4 marks there, you'd get, trying to think how you'd allocate 4 marks. So you'd get at least, you get 1 mark for each of the factorising correctly. Imagine 1 mark for cancelling out the right factor, and then final mark for your answer. I would imagine. Seems a very generous 4 marks. Okay, then we get onto a 6 marker. And if you look at that, that just looks horrendous. But that means it's going to be nice. So show that it simplifies to an integer. So remember, an integer is simply a whole number. So we want to show, that means we have to do all the work in. We can't just like write down an answer. That it goes down, we can cancel all these common factors out and we'll end up with a whole number. So first of all, I look and see I've got an add and I've got a subtract. So let's try and aim to get the same common denominator all the way through. So the biggest denominator is x plus 5x minus 7. So what I'm going to do is I'm going to make the first 2 fractions have the denominator x plus 5x minus 7. So x plus 5, x minus 7. So for the first fraction, I'm timesing by x minus 7. So let's times the top by x minus 7. Second fraction, I am multiplying by x plus 5. So I need to times the top by x plus 5. The last fraction already has the denominator I want. So now I can combine those 3 fractions into 1. With a denominator of x plus 5, x minus 7. So I've got, should I expand the brackets as I go? Yeah, let's expand the brackets as I go. 5x times x is 5x squared. 5x times minus 7, minus 35x, plus 25 times x, 25x, plus 25 times 5. 25 times 5 is 125, minus 300. So let's collect my like terms and see what I've got. 5x squared, 35x minus plus 25x is minus 10x. 125 minus 300 is minus 175. Now, what we're going to do next, right, let's try and factorize, because we're trying to factorize into an integer. We need to factorize the top line. So it's a pretty tough one to factorize. So we know we're going to have 5x and x. Now, we also know that one of the factors is going to be the same as one on the bottom. So does 7 go in? 7 goes in. 2, 30. So 7 goes in 25 times. So we could have 7 and 25. Which is going to work because that's going to give us 35. So that's a 7 and that's a 25. 7 times 5x is 35x. 25 times x is 25x, which gives us that 10x. So we've got this. So we cancel out common factor. Now I can then factorize that top one even more. 5x plus 5 over x plus 5. I can cancel out the x plus 5s and I'm left simply with 5, which is an integer. So as you can see, it's quite a tough, challenging question. You have to be able to factorize and kind of look for your numerical nuances, bits that you can spot that will work. And you sometimes have to like pre-think it. Or you could do some working down the side just to confirm that you've got those numbers right. 6 marker, bit of a toughie. Okay, and last one we're looking at is we've got 2 minus x plus 2 over x minus 3 minus x minus 6 over x plus 3 can be written as a single fraction. So that means one fraction in the form ax plus b over x squared minus 9, where a and b are integers. So again, whole numbers look. Work out the value of a and the value of b. So we need to make it all as one. So first of all, let's combine the two fractions we've got. So let's make our common denominator x minus 3 over, x minus 3x plus 3. So I've times the first fraction by x plus 3 over x plus 3. I'm timesing the second one by x minus 3 over x minus 3. Now, I also want that 2 to be a fraction. So I'm going to times that all by x minus 3x plus 3. Now I'm going to do it rather than write the whole thing out. This is what I've got now. X plus 2, x plus 3 minus x minus 6, x minus 3, and all of that is over x minus 3x plus 3. Now, if we expand it out, x minus 3x plus 3 gives us x squared minus 9, because you have minus 3x plus 3x minus 9, which look is what we are looking for as our bottom line. So we've already got our bottom line. Now to get the top line, we're going to have to do a lot of expanding brackets. So I'm going to do it in steps. So x minus 3x plus 3, I already know expands out to x squared minus 9. And I've got 2 lots of those, so I'll keep that as 2 lots. This one, I'm going to keep it in a bracket and I'll sort out the minus bit afterwards. So I've got x times x is x squared plus 3x plus 2x plus 5x plus 6. Then for the last one, I've got x times x is x squared minus 3x minus 6x, so minus 9x plus 18. All over x squared minus 9. So let's get rid of the brackets altogether. So we've got 2x squared minus 18 minus x squared minus 5x, because it's minus this whole bracket, minus 6 minus x squared minus plus 9x minus 18, because it's minus that whole bracket, all over x squared minus 9. So what have we got? 2x squared minus x squared is x squared minus x squared is 0, so they cancel out. I've got minus 5x plus 9x is 4x. I've got minus 18 minus 6, which is minus 24, minus another 18. So minus 24 minus 34 minus 42 over x squared minus 9. Look at what we wanted, ax plus b. So a is 4, b is minus 42. Good, hopefully, let's just double check. I can't remember if that was another question. Hopefully we're getting our real good idea. Oh, yeah, we've got one more to go. One more, yeah. So this one's a division one. So remember, dividing fractions, keep, flip, change. You always want to be looking to factorize. So I'm going to factorize first. And there are some lovely factorizing going on here. So I'm going to have an x and an x. I want 2 numbers at timescales to make y and y. And I want minus xy, minus 2xy. So that's going to be that. The bottom line, difference of 2 squareds. So that's going to be x minus y, x plus y. So all I'm doing at the moment is factorizing each line. And the bottom one is x, x plus y. So then I'm going to cancel anything that I can before I even do my flip and change. So I can cross out that one and that one. I can cross out the x and the x. So now I've got x minus y over x plus y times x plus y over x minus y. Now remember, when you're multiplying, if there's one on the top and one on the bottom, you can cancel it. So you're just left with 1, because each of those will cancel down to a 1. Excellent, good work. I hope you're feeling more confident with these. And we'll look at the solving equations later on in the course when we were doing the algebraic fractions, because that will bring in the algebraic fraction skills and the quadratic ones. Good. So I look forward to seeing you next time. Let me know if there's anything I can do.